So between negative pi over 3 and 0 on the picture, the tangent of x is larger than 2 sine of x. That's where the graph of tangent is above the graph of sine, 2 times sine. But between 0 and pi over 3, 2 times sine x is bigger than tangent. So we can't write it all as one integral because we want to subtract the bigger minus the smaller. So they got two integrals, and there they are. The setup goes from negative pi over 3 to 0, where you take tangent minus 2 sine x, and then from 0 to pi over 3, where you have it the other way around, 2 sine of x minus tangent x. And now you can solve. This will be a bit of review. It's from calc 1, and the main review here is remembering how to integrate tangent of x. It's a little tricky, but once you've done it a few times, it comes back. Sometimes I forget how to do it, but you write it as sine over cosine, and then let u be the denominator, cosine, and then the u substitution works like this, and you get natural log of the absolute value of u. You put back in the cosine, and then if you look it up in the back of the book, sometimes they do see a natural log of the secant, and that's because of the rule of logarithms, where you can take a multiplier that's out front of the natural log or any logarithm and turn it into a exponent on the inside, and that negative 1 goes on cosine, and 1 divided by cosine is equal to secant. So you can use either of those that you like, the cosine or the secant, and just remembering that cosine is equal to 1 over secant, it might actually be easier to use the cosine. But since that's how I usually find the answer in the tables, I used the secant and then plugged in negative pi over 3 and 0. Alright, well, so first, of course, I had to finish taking the integral. I'll back up real quick and look at the integral. So tangent was the only hard part. The antiderivative of sine is not too hard. Remember that the derivative of sine is cosine, so the antiderivative of sine is going to have to be negative cosine, and so that's where the extra minus comes from. I get a minus minus, or plus 2 cosine on the first integral, and I got a minus 2 cosine on the second integral. Then I'm very careful with all those negatives. I plug in 0 for x, secant of 0. If I remember, that's 1 over cosine of 0, and I remember that cosine of 0 is equal to 1 from the unit circle or from the graph of cosine. Then I'm getting a natural log of 1, which is going to simplify nicely because natural log of 1 is equal to 0. So natural log of 1 is 0, and so that's going to help at the very beginning and at the very end, where I plug in another 0. And then pi over 3. So for pi over 3, you have to plug that into cosine, and you do get 1/2 when you plug in pi over 3 to cosine, but secant of it is 1 over that, so 1 over 1/2 is 2. So that's why I'm getting a 2 for the pi over 3 values, or the negative pi over 3 values, which you can also use a calculator to help with. And after simplifying, you make sure you keep track of all those minuses. There's as many as 3 negatives in a row, but that one place is where there's 3 minuses in a row will be 0 anyways, but you do have to be careful that the double negative is a positive 2. And so I get 1 minus natural log of 2, 2 plus 1, or 2 minus 1 gives me the 1, and then minus natural log of 2, and I get that same answer again for the second integral, 1 minus natural log of 2. And the note at the bottom says I could have noticed, if I knew a little bit more about trig functions, that those two areas that were shaded are the same exact shape and size. So I could have just found one of them and said, the answer is twice that. It's 2 times 1 minus natural log of 2, or 2 minus 2 natural log of 2. And doing it twice, though, doing it the way that I did it all the way through, is a nice double check. So for the final answer, I would like for the answers to be left with numbers like natural log of 2, pi, and e, the transcendental numbers. In other words, leave them in their precise format. Don't turn them into decimal. I'll make sure I make a note of that on various homeworks and quizzes and tests. But other than that, you can. It's up to you how much to simplify the answer. You should add together any whole numbers and multiply together any whole numbers, but it's okay to leave things like square roots and fractions in place.